I always forgot like this. Okay. So for this case, if we apply the normal and tangential coordinate system, you can see that this is the NT should be here. Okay, it's maybe not convenient to use NT's coordinate system for this problem because we already know the part in terms of r theta, and it's maybe better to solve in r theta instead of xy because we know, as we know that we know the part in terms of r theta instead. Okay, and if we consider the point, this point, if the particle is here, is in this point, the tangent is maybe in the blue line direction. Okay, and if we compare with the r theta, with the r theta, so for r it should be like this. This is r. Okay, so this is the direction of r. Okay, that's for this case you will see that the line of r and n is the accidental. For this case is accidental coline. Okay, and you will see in next is maybe not. Okay, and then if it's something like this, theta is maybe like that. Actually is I think it's maybe it should be not, but because this is the handwriting, right? So then normal and tangential and r theta for this case at this point is accidental coline from the picture. Okay. And if we consider point P at this point, the tangent of the part is maybe here. I draw the tangent. Okay, and normal is maybe here. Okay, but for R, we represent from this point. R direction should be like this. Okay, you see that R and N is not collide to each other now. And also for theta, it should be here. Okay, do you understand better now? Okay, about the normal and tangential direction and R and theta direction. Okay, and if particle is moving here, okay, what next? Tangent should be here, right? Should change color. Tangent should be here. Normal should be here. Okay, how about R? R is become like this. This is R. Okay, and theta should be here. Okay, you see that tangent and r theta for this case is not colline to each other like the circular motion anymore. But for this case, you see that if we use normal and tangential direction, okay, it's maybe let us confused about the direction because we have no idea the particles is moving along the path, and it's hard to find the radius of curvature, right? Okay, if the particle is here, can you find rho at this point? Okay, it's maybe a little bit. Actually, we can. Okay, but it's maybe how to convert some term, right? Okay, and at this moment, it's not straightforward to determine rho. Okay, at this point, and it's not straightforward to determine rho at any point. Okay, because we don't know exactly the part in terms of x and y. If we know in x and y, we can use the formula of the rho that we apply for this case. Okay. Okay, that is we have to convert it to x and y also. And also for the case of acceleration in x and y, we have to change this term. Okay, we have this relationship that is r square equal to 4 cosine 2 theta, right? So what does it mean? It means that r equal to square root of 4 cosine 2 theta, right? Okay. So if we convert it to x equal to r cosine theta and y equal to r sine theta, that's actually in polar coordinate system, we can do it. Okay. And you will see that theta, r is a term of theta also. Okay, but it is not the directly to that. Okay, it's not directly to that. It is the in term of square root. So we have to substitute into this again. Okay, so then it's make us a complicated one term. Okay, because we have the term of theta dot here. Okay, so x, y, actually we can solve, but it's maybe not convenient, right? Okay, so it's maybe better to solve, keep it in terms of r theta instead. Then we understand better for this case. Okay, so then let's start for this problem. Okay, to this problem, if we solve for the case of we would like to find the velocity and acceleration of the bag at theta equal to 30 degrees, right? And we know that when time equal to 0, theta is 0. Okay. So according to this, we know that from the formula. Okay, from the formula is what? We have VR equal to R dot. Okay, V theta equal to R theta dot. Okay, and AR equal to R double dot minus R theta dot square. Okay, A theta equal to R theta dot double dot plus 2R dot theta dot. Okay, it's just in polar coordinate system. So then our work is just find all derivative term that is composed of R dot, theta dot, R double dot, and theta double dot, right? Okay, so for this case, we starting with the time derivative. For the time derivative, we starting with the first one. We know that r square equal to 4 cosine 2 theta, right? Okay, so we take the first derivative to this equation, both sides. On the left hand side, we obtain 2r, right? And r dot. On the right hand side, okay, according to the chain rule, okay, we take the first derivative to r square with respect to time. It's become 2r and dr by dt. dr by dt is mean r dot. Okay, dot is equal to d by dt. Okay, and for this case we have 4, right? And take the first derivative to this, it's become minus sine 2 theta. Okay, and we have we take the first derivative to this term again, it's become 2, right? and theta dot. Okay, this is the chain rule. Okay, we take the derivative to cosine 2 theta, it's become minus sine 2 theta. Take the derivative to 2 theta again, it's become 2 with d theta by dt, that is theta dot. Okay, according to this, we can derive for r dot, that is become minus 4, okay, theta dot sine 2 theta divided by r. Okay, yes, we have this term now. Keep it, and the unit of this is become meter per second. And after that, we would like to find r double dot, right? Okay, we would like to find r double dot. Actually, you can take the derivative to this term also, but I will select this equation instead. That is maybe better. Okay, I take the derivative to this equation, this clean one instead. Okay, we got to r double dot plus r dot. Okay, it says depend. Okay, you may take the derivative to this term. That is up to you. It's all right. Okay, but you have to keep in your mind that you have this term again. Okay, and it's become what? It's become minus 8 theta double dot sine 2 theta. Okay, minus 8 theta dot cosine 2 theta and 2 theta dot. Okay, according to the chain rule. And we rearrange this equation again. Okay, we obtain r double dot, as you may working out by yourself. We obtain r double dot equal to minus 4 theta double dot sine 2 theta plus 2 theta dot square. Okay, cosine 2 theta minus r dot square. Okay, divided by r. Okay, we obtain this term now. Okay, so then we substitute when theta become 30 degrees. Okay, that is actually is equal to pi over 6 radian. Okay, so it has to remind us that when we working in polar coordinate system, okay, angle should be converted to be in radian first. Okay, do not leave in degree. Okay, you will see that we have the term of theta dot and theta multiply with our term. Okay, so we should convert the angle to be radian first. Okay, and do not forget to convert your calculator also. And after we substitute this term with the additional given value, that theta dot equal to 4p power 3 over 2. Okay, we know that theta dot from the problem, we know that this is 3 power 3 over 2. Okay, so according to this, we can determine theta by integrate this term. that is 4t power 3 over 2 dt. Okay, that we will get after you complete the integration. We got 3 power 5 over 2 over 5 over 2, right? Plus c. Okay, but with the initial condition that when t equals 0, theta is become 0. Okay, so for this case, we found out at time equals 0, theta becomes 0. So then it means that c is become 0. Okay, that's why we got theta is equal to 8 over 5. Okay, t power 5 over 2 now. Okay, we have this term. And after that, we substitute the angle theta in radian. Okay, we have to substitute it in radian. Do not substitute in degree. Okay, theta equal to 30 degrees mean pi over 6. Okay, it means pi over 6. So for this case, we substitute theta equal to 30 degrees. That is equal to pi over 6 here. And we obtain pi over 6 equal to 8 over 5 t power 5 over 2. Okay, so for this case, we can solve for t, that is become 0.6397 seconds. Okay, that is give us that after we get time. Okay, we can solve for theta dot now. So then theta dot, we know that is equal to 4t power 3 over 2, right? And we substitute time here. And we get theta dot now is become 2.047 radian per second. Okay, it is theta dot when theta equal to 30 degrees. And also for case that theta double dot. Okay, for theta double dot is what? We take the first derivative here, that is become 4 times 3 over 2. Okay, and t 1 over 2, right? Okay, let's become 6. Okay, that is now we obtain that when time equal to 0.6397, we got theta has become that is 4.7989 radian per second square. Okay, and now we obtain actually it should be all term now. Okay, so for the case that we would like to find VR, right? VR is R dot. Okay, so for R dot is what? Okay, R dot is equal to, we already derived. Okay, R dot is equal to minus 4 theta dot. That's now we already know theta dot is 2.047. Okay, sine 2 theta, 2 theta now. In this term, you may use the angle in degree if it is in the sine term. Okay, but actually I recommend you to use it in radian. Okay, and it's equal to 2 pi over 6. Okay, and divided by r. Okay, divided by r. But now r is what? Okay, for r, we know that r is equal to square root of 4 cosine 2 theta, right? That is for the case, it's become root of 4 cosine pi over 3, right? That's become 2. Okay, so then we substitute back into here. R is now is equal to square root 2. So then after that, we got VR become minus 5.014 meter per second. And for V theta is equal to R theta dot. R now is equal to square root 2, right? And theta dot is, we already have. And then we get okay, that we can write in the vector form like this. That is minus 5.0. This is in direction of R plus direction of theta. That is the magnitude of velocity is become of this term. That is equal to okay. That is our solution here. That is we would like to find the magnitude of velocity, and then we back to the acceleration. For the acceleration, AR is double dot, right? Okay, minus theta dot square. Okay, so we have to find double dot first. Double dot is what? Substitute double dot when theta equal to 30 degrees. Okay, it's become minus 4 and 4.7989. Okay, because we know theta double dot, right? And sine pi over 6, oh sorry, pi over 3, and plus substitute each term into here. Minus r dot square. R dot is now okay divided by 2. Okay, and we obtain R double dot is become okay. So then we substitute this value back into AR, and we get and we obtain that the AR is equal to minus 47.3. Okay, and same manner for A theta. Okay, we do the same thing. A theta is equal to R theta dot dot minus 2R dot theta dot. Okay, and substitute each term. That's you already know, right? Okay, you may substitute by yourself. That is, we obtain about minus 13.74 meter per second squared. And after that, the magnitude of A is become square root of this term. Okay, and after you solve, okay, you get 49.26 meter per second squared. Okay, this is I still have no space now. Okay, so then you may like by yourself. Okay, so that's the some complete of this problem. Okay, so then for to this problem, you will see that it's maybe a little bit complicated in mathematical term. So, but it's maybe better than solving in X, Y, and in normal and tangential coordinate system, because for the case of particular case that we have to solve in this part, in this problem, that's particles moving along this part, this type of part. Okay, so polar coordinate system is maybe better. Okay, let's complete this problem.